In lesson 9.7, we will be studying variation. We study variation here in this chapter because we'll end up solving rational equations. There's three types of variation we'll be talking about. There are more than just three types of variation, but we'll be just studying these three. The first one is direct variation, and you'll see that as y varies directly as x, which in the equation form means y equals k times x, where k is a positive constant, and it's called the constant of variation. Varies directly means really as x increases, y will also increase. So it varies directly. Whatever the one does, the other one will do. The next type of variation is inverse. We'll read that as y varies inversely as x, or whatever variable that they put in there. This means that y equals k over x, so this is a rational equation, where k is still a positive constant and again called the constant of variation. In varies inversely equations, as x increases, y will actually decrease because you're making the denominator larger, which makes the y value smaller. And then there's joint variation or combined variation. This means that some value varies with more than just one variable. It could vary directly or inversely. If it doesn't say directly or inversely, we assume it's directly, especially when we see joint variation. This is a helpful hint. In general, directly means the variable will be in the numerator and multiplied by k, and inversely means the variable will be in the denominator and will divide k. So we'll work through a few examples here to nail this down. The first two are pretty straightforward. What we have here, if y varies directly as x and y equals 8 when x equals a half, find y when x equals 4. So y varies directly as x. Since we see this right here, we know that we're going to use the equation y equals kx. And what we're going to do for this is we're going to figure out what our constant of variation is. Once we know that, we can write our general equation and go ahead and find the value when x is equal to 4. So what we do is we use our first situation here. Y equals 8 when x equals half. So we're going to go ahead and write y is equal to 8 when x is equal to a half. And again, this will help us find k. Well, to get k by itself, we're going to multiply both sides by 2. And we see that 16 equals k. Once we find our constant of variation, we go ahead and write our equation. Instead of putting k in, we know that k is 16, so y equals 16x. And that's our general equation for this situation. We can go ahead and find y when x equals 4. So finally, to answer our question, we're going to plug in 4, and we see that y is equal to 64. And that's the answer to that, which this was a couple steps. First, we wanted to use the equation to help us find k. Once we found k, we wrote our general equation. And then once we have that, we can find the y value when x equals any number, in this case, when x was equal to 4. Jumping right into the next example, we see that y varies inversely as x cubed, and y equals 16 when x equals 2. Find y when x equals 8. Well, inversely, we know has to do with dividing. So we have y equals k over, and it varies inversely with x cubed, so we're going to put x cubed here. So that's the equation we need for varies inversely. We're going to go ahead and plug in the specific situation, y equals 16, when x is equal to 2. And by plugging that in, we can solve for k. And so this gives us 16 equals k over 8. We're going to go ahead and multiply both sides by 8. And we get k is 128. To finish solving this, we can go ahead and write our general equation now. Y equals 128 over x cubed. And we can plug in the value to help us find y. So it says find y when x equals 8. So y equals 128 over 8 cubed. Eight cubed is equal to 512. Now both of these are powers of 2, so I want to go ahead and reduce here. 128 goes into itself one time, and I believe it goes into 512 four times. So this is equal to 1/4. Y equals 1/4 is our answer. There's definitely application to this. We see in physics or chemistry some relationships. So here we have, if the temperature remains constant, the volume of a gas varies inversely with its pressure. Real quickly, that just means the more pressure you have on the gas, the less volume it's going to be. If a certain gas has a volume of 25 cubic inches at 15 pounds per square inch, known as psi, and the pressure is increased to 20 psi, what is the volume of the gas after the pressure increase? So very importantly, we have the volume of the gas varies inversely with its pressure. So instead of using y and x, I'm going to use volume varies inversely, so I'm going to do k over, and it varies inversely with the pressure, so I'm going to put p here. And then it gives us our first situation. A certain gas has a volume of 25 cubic inches at 15 psi's. Well, cubic inches measures volume, so we can plug this in. 25 cubic inches at 15 pounds per square inch. And solving for k, we would multiply both sides by 15. And we get k equals 375. So that's our constant of variation. We can now write our general equation. We know that the volume is going to equal 375 divided by p. And we can find the answer to our question. It says the pressure is increased to 20 psi, so we're going to go ahead and put 20 in for our pressure. What's the volume of the gas? So we just take 375 and divide it by 20, and we get 18.75, and this would be measured in cubic inches, or inches cubed. And notice as we increased the pressure, the volume decreased. Last one, write the general equation for y varies directly as the sum of x and z, and inversely as the square of x. So it's a y varies, so we're going to have y equals, and this is a combined variation. It varies directly, so as I mentioned before, if it varies directly, it's going to go in the numerator with k. It's going to be multiplied times k, and it varies directly as a sum. So we're going to put a sum is multiplied times k, and the sum is x plus z. And inversely as the square of x. So that means that part's going to go in the denominator because it's inversely, and so that's just over the square of x, which we write as x squared. And that's the general equation. So those are variation problems. You can now work with direct variation, inverse variation, and joint or combined variation.